Have you ever wondered how clouds form? Maybe you've noticed icicles dripping on a sunny winter day. Or perhaps you've seen the outside of a cold soda can get moist on a warm, humid afternoon. These phenomena are the result of changing phases of matter. What is a phase of matter, and how does matter change from one phase to another? Why do phase changes occur, and why are they important to us? During the next few minutes, we're going to answer these questions and others as we explore changing phases of matter. This person is cutting water with a chainsaw. You decide. What form is the water? That's right. The water is in the form of ice. It's a solid. One of the amazing properties of water and other substances is that they can exist in three different forms: as a solid, a liquid, and a gas. Even though water can exist in these very different forms, it's still water. Phases of matter, also called states of matter, are the physical forms that matter can take. There are actually four phases of matter: solid, liquid, gas, and plasma. While plasma is not commonly found on Earth, it is commonly found in stars such as our Sun. We'll talk more about plasma in a few minutes. Even though you can't see them, billions of tiny particles make up this pencil. All matter, even matter you can't see, is made up of particles. Tiny particles, in their smallest form, consist of atoms and molecules that are far too small to be seen with the naked eye. Particles that make up matter are constantly vibrating and bumping into each other. The various states of matter are determined by the motion and speed of particles. Understanding how particles move helps explain how matter behaves and changes phase. You compare. Describe how this piece of solid ice is different from liquid water. The ice is rigid and solid, whereas the liquid water flows easily and takes the shape of the container that holds it. Why is liquid water so different from ice? The answer lies in the behavior of water particles found in liquid water and ice. The particles in solids are packed closely together. The particles move, but not as much as in liquids. Particles in solids vibrate, but they're more or less locked into place. Therefore, solids, such as ice, have a definite shape and a definite volume. This is why it takes a great deal of effort to reshape a solid. Liquids, on the other hand, such as orange juice, have a definite volume but do not have a definite shape. For example, this beaker contains juice. Notice how the liquid takes on the shape of the container. When poured into this container, it takes on a different shape, but it still has the same volume. The reason liquids behave the way they do is because the particles in liquids, while still packed closely together, move more freely past each other. Unlike solids and liquids, gases have no definite shape and no definite volume. If you put a gas in a container and place a lid on it, the gas particles spread out or squeeze together to fill the container. In other words, the volume and shape of a gas changes according to its container. Particles in gases fly at high speeds in all directions and are not arranged in any set pattern. This makes it easy for gas particles to move around, spreading apart or moving close together. The fourth state of matter, plasma, has different properties than solids, liquids, or gases. Plasma, such as that found in stars, has no definite shape or volume, and its particles have broken apart. Natural plasmas are found in lightning, stars, and fire. Artificial plasmas are found in fluorescent lights and are created by passing electric charges through gases. You predict. What will happen to this ice cube if left on a warm windowsill? Over time, it changes from a solid to a liquid. This is an example of a phase change. A phase change is the change of matter from one phase to another. Phase changes occur when energy is added or taken away from a substance. For example, when enough energy is added to a solid, it will eventually melt. Melting involves the phase change of a solid to a liquid. The melting point of a substance is the temperature at which a substance changes from a solid to a liquid. The melting point of water, for example, is 0 degrees Celsius, or 32 degrees Fahrenheit. The melting point of salt is much higher, at 801 degrees Celsius. The opposite of melting is freezing. Freezing is the process where a liquid changes to a solid. In this process, heat is removed from a substance. Particles move slower to the point where they become locked into place as a solid. The freezing and melting point of water is 0 degrees Celsius, or 32 degrees Fahrenheit. Have you ever left a glass of water on the shelf for several days and noticed that the water eventually disappeared? Why did this occur? This is the result of a phase change called vaporization. Vaporization involves a phase change of a liquid to a gas. In the process of vaporization, particles absorb enough energy to escape the liquid phase. When vaporization occurs at the surface of a liquid, the process is referred to as evaporation. Evaporation is occurring all around us in places such as mud puddles, lakes, and even off the surface of our skin. In this process, liquid water changes into water vapor. Water vapor, even though we can't see it, is present in the air around us. Vaporization not only occurs on the surface of liquids, but within liquids as well. If enough heat energy is supplied, particles in a liquid can change to a gas. You observe. Describe what you see in this container of water. You can actually see vaporization occur as gas bubbles form and travel to the surface. This process is called boiling. Perhaps you've boiled water to cook food. The boiling point of water in normal conditions at sea level is 100 degrees Celsius, or 212 degrees Fahrenheit. The opposite of vaporization is condensation. Condensation occurs when the particles in a gas lose energy, slow down, and change phase into a liquid. Condensation can also occur on the side of a cold soda can, as water vapor particles of gas turn into droplets of liquid water on the outer surface of the can. Condensation is also the process by which clouds form. As warm, moisture-rich air containing water vapor rises, at some point the atmosphere air cools enough to condense. When it condenses, billions of tiny liquid water droplets form a cloud. If you live in a place where winters are cold and snowy, you may have noticed that snow mysteriously disappears even when temperatures are well below freezing. This is due to a process called sublimation. Sublimation occurs when the surface particles of solids gain enough energy to become a gas. In this process, particles do not pass through the liquid state. Another example of sublimation occurs in dry ice. Dry ice is actually solid carbon dioxide. At room temperature, dry ice goes through a phase change from a solid to a gas without going through the liquid phase. During the past few minutes, we've explored the changing phases of matter. We began by briefly discussing the 4 phases of matter: solids, liquids, gases, and plasma. The arrangement and movement of particles in the various phases of matter were discussed. We then investigated the characteristics of different phase changes, including melting, freezing, vaporization, condensation, and sublimation. So, the next time you watch ice melt, touch a moist soda can on a warm afternoon, or boil a pot of water, think about some of the things we've discussed during the past few minutes. You just might think about the changing phases of matter a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. There are phases of matter. Number 2. Liquids have a definite volume and no definite. Number 3. Phase changes occur when is gained or lost from a substance. Number 4. Occurs when a liquid changes to a solid. And number 5. Involves a phase change of a liquid to a gas.